Today we're going to talk about loans and amortization. Generally speaking, when someone takes out a loan, they make partial payments on a regular basis. Loans are generally paid off by a series of partial payments with interest charged on the unpaid balance at the end of each payment period. The process of repaying the loan by making payments of equal size is called amortization. Most people at some point in their life will have to take a loan out for something. Maybe you already have for student loans. Most people, when they buy a brand new car, can't pay cash, or they buy a house, they can't pay cash. So amortization is something a lot of people end up doing. So here's the amortization formula. R equals A sub n, now A sub n is one variable by itself, times I over 1 minus 1 plus I raised to the negative n. Notice that exponent is negative. A sub n is the total loan amount. That's the amount of money you had to borrow. R is the continual periodic repayment amount, how much you pay back every month or every quarter or every half year or something like that. I is the interest rate per period found by R divided by M, where R is the interest rate turned into a decimal, and M is the number of compounds. And N is the number of investment periods found by M times T. M is still the number of compounds, and T is the time, usually in years. So let's take a look at an example. A man buys a house for $250,000. Now notice he puts down a $50,000 down payment. So then he agrees that the rest of the debt will be amortized with monthly payments over 20 years. If the interest of the loan is 4.8% compounded monthly, what is his monthly mortgage payment? Now look closely. He didn't have to borrow $250,000, which is the cost of the house. He was able to pay $50,000 up front. So how much did he actually borrow? Let's find the components. He actually borrowed $200,000. I equals R over M. Take that 4.8%, turn it into a decimal, and divide by 12. And then N equals M times T. That 12 payments a year times 20 years means he's going to make 240 mortgage payments. So now we have all the components we need to plug in and try to find R, his mortgage payments. Now, do any basic simplifications first. Take this 1 plus 0.004. Don't try to do too much in your calculator at one time. Simplify it. Make it easier for you. Take this 1 minus 1.004 to the negative 240th power. Put that in your calculator first. Now, like we've done before, save all your rounding for the very end. Take these two numbers and divide them. And now you're ready to multiply and distribute that 200,000 in. And you get 1,297.91494. Now R represents his equal payments, which we refer to as his mortgage payments. So turn that into dollars and cents. He has to pay $1,297.91 every month. That's his monthly mortgage. Now let's expand a little bit more on this example. What was the final price of the house? Now the cost of the house itself was $250,000, but he couldn't just pay $250,000, he had to borrow $200,000. So he doesn't just pay back $200,000, he also has to pay the bank interest. So the man makes his mortgage payments 12 times a year for 20 years. Plus, don't forget he already paid $50,000 up front. So he takes his monthly mortgage payment of $1,297.91. He pays that amount 12 times a year for 20 years, plus that down payment. Put it all together, and it's $361,498.40. So the final price of that $250,000 house he bought, it actually cost him $361,498.40. So how much did he pay in interest? Well, he paid $360-something thousand for that $250,000 house, so take the final price that he paid minus how much the house cost, and it turns out he paid $111,498.40 in interest. That's a lot of interest. Now I have another definition for you. The unpaid balance of a payoff amount of a loan. Now, the variable a sub n minus k, this is all part of it. This is one big variable, equals r times 1 minus 1 plus I raised to the negative n minus k over I. A to the sub n minus k, that's the unpaid loan amount. That's how much you have left on your loan. R is the continual periodic repayment amount. Could be your car payment, could be your student loan payment, could be your mortgage. I is the interest rate per period found by R over M, where R is the interest rate and M is the number of compounds. That should look familiar. N is the number of investment periods found by M times T. That's how many payments you're supposed to make, where T is time, generally in years. Now K, this new variable, that's the number of periods you've already paid. That's the number of car payments you've already paid. That's the number of mortgage payments you've already paid, something like that. So then when you take N minus K, that's how many payments you have left. So for example, a $10,000 loan is to be amortized for 10 years with 6% interest compounded quarterly. What is the unpaid balance after the sixth payment if quarterly payments are $334.27? So after you've paid these equal payments of $334.27, after you've paid 6 of them, if you wanted to pay off the rest of your loan to save on interest, how much do you have to pay? Okay, so let's break down the components. R is 334.27. That's your equal payments you've been paying every quarter. I is R over M. That's 6% interest divided by the number of compounds 4. N is N times T, or 4 times 10, which is 40. So you're supposed to make 40 payments. You've made 6, so you have 34 left. So now that's all we need to plug into our formula. So our payoff amount that we have left will be our equal payments of $334.27 times 1 minus 1 plus 0.015 to the negative 34, the remaining periods we have left, divided by 0.1015. As before, do your basic simplifications first. Now let's simplify the numerator. 1 minus 1.015 to the negative 34th power. Save your rounding for the end. Divide these two. Now you're ready to multiply by that 334.27. So if you wanted to pay off that loan today, you would need to write a check for $8,852.05. We'll expand a little bit more on this the next time I see you.